Welcome back to another video by Adeptis Academy. Imagine your home where everything has its place: books on shelves, clothes in closets, plates in cupboards. This sense of order brings peace of mind and makes daily life run smoothly. In the digital world, we face the same challenge: organizing contacts, photos, music, and emails. Without a system, finding a specific file can be overwhelming. Databases and data structures are our digital filing cabinets. They bring order to the chaos, making sure everything has its place. A database is like a highly organized electronic filing cabinet, storing information with rules for adding, updating, and retrieving data efficiently. Together, databases and data structures are the backbone of technology, powering everything from social media to online shopping. Organization, physical or digital, brings order to chaos. Let's explore how these invisible systems shape our everyday lives. Think of a public library, not just a building of books, but a place where knowledge is carefully organized and managed. Every book has its place, thanks to a cataloging system that makes finding information easy. A database is the digital version of this system, managed by software called a Database Management System, or DBMS. The DBMS acts as your digital librarian, storing, retrieving, and updating information quickly and securely. For example, when you add a contact to your phone, you're adding a record to a database. Databases help businesses manage thousands of records, search for information instantly, and keep data safe. From small shops to global enterprises, databases are essential for organizing and protecting information. That's the power of a database, keeping your information organized, secure, and always within reach. The most common type of database is the relational database. Picture a library with several linked notebooks, one for members, one for books, one for checkouts. Each notebook is a table, like a spreadsheet, with rows and columns. Tables are linked by unique keys connecting related information. For example, an orders table links to customers by a customer ID. This structure is organized and predictable, like Lego blocks that fit together. The language used to interact with these databases is SQL, Structured Query Language. With SQL, you can ask precise questions like finding all customers in New York. Relational databases are everywhere: banks, online stores, and more. Their strict rules ensure data integrity, no orders for non-existent customers. This reliability makes them the backbone of business applications. They're trusted, dependable, and built for structured data. When your data has clear relationships, relational databases shine. They're the workhorses of the digital world. Now imagine a creative scrapbook, each page unique with photos, notes, and mementos. NoSQL databases work like this: flexible, freeform, and adaptable. NoSQL means not only SQL. They break from the rigid structure of relational databases, perfect for messy, varied data like social media posts where each record can be different. Document databases like MongoDB store flexible, JSON-like documents. Key value stores like Redis are like giant dictionaries, super fast for lookups. Other types include column, family, and graph databases, each for specific needs. NoSQL excels with massive, rapidly changing, or unpredictable data, used by tech giants for real-time analytics, content management, and IoT. When data doesn't fit a neat table, NoSQL adapts on the fly. It's the storage system for the fast-paced, ever-changing digital world. If a database is the filing cabinet, data structures are how you organize the files inside. They're the building blocks programmers use to handle data efficiently. The right data structure makes programs faster and more memory efficient. Think of a grocery list. Is it numbered? Can you add items, cross them off? Different structures suit different tasks. Some are great for searching, others for adding or removing items. Like a chef choosing the right knife, a programmer picks the right data structure for the job. Mastering data structures is key to creating responsive, effective software. One fundamental data structure is the array, like a bookshelf with numbered slots. You can access any slot instantly, making arrays fast for direct access. But arrays have fixed sizes. Adding more means creating a new, bigger array. Inserting in the middle requires shifting everything over. Enter the linked list. Imagine each book has a note pointing to the next. Books can be anywhere, and adding a new one is easy. Just update the notes. The trade-off? To find the fifth book, you must follow the chain from the start. Arrays are best for quick access by position. Linked lists excel at frequent additions and removals, especially in the middle. The choice depends on your needs, speed, or flexibility. Both are essential tools in a programmer's toolkit. Arrays and linked lists solve different problems in data organization. Knowing when to use each is crucial for efficient software. Let's explore two more essential data structures: stacks and trees. These structures are fundamental building blocks in computer science, shaping the way information is stored, accessed, and managed in countless applications. A stack is like a pile of plates. Add to the top, remove from the top. This is called last in, first out, or LIFO for short. The last item you put on is always the first one you take off. Stacks are used for things like managing function calls, keeping track of what needs to be done next, and powering the undo feature in apps. They're also crucial in parsing expressions and navigating back through web pages. Simple but powerful for tracking sequences in reverse order. Stacks help keep operations organized and efficient, especially when you need to backtrack or reverse actions. Now, picture a family tree. One ancestor at the top, branching down to children and grandchildren. This is a perfect analogy for tree structures in computing. In computing, a tree has a root node at the top, with child nodes branching out, and leaf nodes at the ends. Each connection represents a relationship, creating a clear hierarchy. Trees are perfect for representing hierarchies, like your computer's file system, organizational charts, or even website navigation menus. Special trees, like binary search trees, keep data sorted for fast searching, quick updates, and efficient organization. They make finding information much faster than searching through a list. Trees combine the benefits of arrays and linked lists, offering fast search, easy insertion, and flexible structure for complex data. They're used everywhere, from organizing files and databases to powering search engines and artificial intelligence algorithms. Stacks and trees help manage complex data and operations, making software more reliable and easier to maintain. Each structure has unique strengths for different problems, and choosing the right one can make a huge difference in performance. Understanding them unlocks efficient solutions in software, helping you write code that's both fast and effective. They're the backbone of many digital systems, quietly powering the technology we use every day. Mastering stacks and trees is key for any programmer, opening the door to building smarter, more efficient applications. So how do databases use data structures? Relational databases store rows like arrays for dense storage, but searching millions of rows would be slow. That's why they use indexes, special data structures, often B-trees, for lightning-fast lookups. Instead of scanning everything, the database jumps straight to the right spot. NoSQL databases might use hash tables for instant key-based retrieval or tree-like structures for nested data. The choice of structure matches the data's shape and the task's needs. Efficient data structures make databases powerful, fast, and scalable. Databases and data structures aren't just for engineers. They shape your daily life. Every time you check the weather, scroll social media, or stream music, you're using these systems. They make apps fast, searches instant, and information always available. Shopping online, getting directions, or sending a text, all rely on efficient data organization. Without them, digital life would be slow and frustrating. The speed and convenience you expect is built on decades of data structure innovation. Understanding the basics gives you a new appreciation for technology. These concepts bring order to the chaos of information. They're the quiet tools that make our connected world possible. Behind every seamless experience is a foundation of smart organization.